Hello students, welcome back. In chemistry we are discussing about the energy of the electron. We take the example of Bohr model and it quantized energy. Okay, Bohr model for hydrogen atom means one electron system. The scientist Bohr gave the hydrogen spectrum in the form of postulate. In that number 1, postulate number 1, electron can move around the circular part of fixed radius and energy. So electron can revolve around the particular fixed part around the nucleus. That fixed part is nothing but is orbital. Its radius is fixed and the energy also is fixed. Second, energy of the electron in an orbital is fixed, that is quantized. Each orbital have different energy level and each level is quantized. Electron can move if it has sufficient quantized energy, then only electron can revolve around the particular nucleus in an orbital. Electron can move from one orbital to another orbital. Means if the energy of the electron is increases, then that electron absorbs the energy and goes to higher orbital state, and then it revolves around by absorption of energy. So electron move from one orbital to another orbital by absorption. If it absorbs the light, then it goes to higher level. If it emits light, then it comes lower energy orbital. So emission of the light will take place and electron comes down and rotate around the inner orbital. Frequency of that particular energy absorb or emit is given by the equation E is equal to h mu. Okay, we have derived this equation that energy is directly proportional to frequency mu, where h is a Planck constant. E directly proportional to mu and h is the Planck constant, 6.626 into 10 raised to minus 34 Joule. Therefore, V is equal to E by h. V or mu is equal to delta E by h, where delta E is nothing but the difference in the energy level between the two orbitals. If one designate as E2 and other designate as E1, then difference in the energy E2 minus E1 upon h, that is nothing but frequency, that is mu. So you can find difference in the energy divided by Planck constant, then you get the frequency. Similarly, from frequency you can find the wavelength as well as wave number of the particular electron related with its energy level. Postulate number 4, the angular momentum. Electron is revolving around the orbit nucleus in an orbital, so that rotation is the angular. Momentum means change in velocity of an electron in an orbital is integral number of h upon 2 pi. So mass me means it is the electron mass or weight of an electron. Mass into velocity into radius, so that is nothing but it is angular momentum. So angular momentum is equal to nh upon 2 pi, where n is a integral. Integral number means what? First orbital, second orbital, third orbital, 1, 2, 3, 4 onwards. So this is about angular momentum. So these are the 4 postulates related with the Bohr atomic model. We move forward in this. Okay. We try to find the energy level of an electron which is revolving around the orbital. We have already discussed about the postulate related with the hydrogen spectrum. The stationary state of electrons are the numbers. So in that equation, that number 1, 2, 3, 4 is nothing but the orbital numbers. This number is also known as principal quantum number. The number indicates about the energy. If number is 1, then energy level is less. If principal quantum number is 2, quanta number, that energy number is higher. Radius of a stationary state. When electron is in stationary state, then its radius can be found with the help of certain factor, that is A0. Its value is 52.9 picometer. If you want to find the orbital radius of second or the third orbital, then it is what? N square A0, where n is a number 1, 2, 3, 4 onwards. So you can find the radius of the orbital from the nucleus. For atom other than hydrogen, then you have to divide by certain numbers. Okay, it's atomic number. Suppose hydrogen, then you have Z is equal to 1, atomic number of the elements. If it is helium, then Z is equal to 2. Similarly, carbon, then it is 6. So for a particular atom, we want to find the radius. Then that electron is in which orbital? That you have to write. That is principal quantum number 1, 2, 3, 4. So Rn is equal to n square A0, that is 52.9 km, divided by Z, that is atomic number of the element. Then you can get the radius, and from radius you can find the area and volume of the particular atom. Next, C. Energy of the electron in a stationary. When electron is rotating in the stationary orbit, no absorption and no evolution of energy is there. Then En is equal to RH into 1 upon n square. 1 upon n square is nothing but the number, okay, principal quantum numbers. Suppose we are talking of the electron in an orbital, then we have to write just En is equal to RH upon 1 upon n square, okay, principal quantum number square. This RH is nothing but it is Heisenberg constant. Its value is 2.18 into 10 raised to minus 18 joule. So if you want to find the energy of suppose second principal quantum number, then put this value 2.18 into 10 raised to this upon 1 by 2 square. So it is 1 by 4. So its value is decreases. Energy is decreases. Similarly, if you want to find radius or energy of other atom, instead of hydrogen we want to find boron. The boron number is 5. So it is 5 square upon n square. For multi-electronic system, atomic number change. For that, En is equal to minus RH Z square upon n square. Another equation you can find from this, that if electron jump from particular orbital to particular orbital, then what will be its energy? Then energy equation we know, E is equal to h mu. Energy is directly proportional to frequency. So E is equal to h mu. So mu, frequency, is equal to E by h. E by h, h is a Planck constant. Energy you can find from this equation. So we can get the equation for frequency. If you put the values, then you will get the value mu, that is frequency, is equal to 3.29 multiplied by 10 raised to 15 into bracket 1 upon Ni square minus 1 upon Nf square. Ni and Fa. Nf is initial and final state of the orbit. Its value may be higher or lower, or electron from one orbital it goes to higher orbital, or from higher orbital to lower orbital. So absorption and emission frequency can be calculated with the help of this equation. Again I revise, mu is equal to 3.29 into 10 raised to 15 into bracket 1 upon Ni square minus 1 upon. Instead of frequency you can find wavelength also. Why? Because mu, frequency, mu is equal to c by lambda. Okay, c value, that is velocity of light, lambda that is wavelength. So you can find wavelength of the particular light emitted or absorbed from the equation. Another factor, that is wave number, V bar. So wave number also you can calculate by this equation. Wave number V bar is equal to 1 by lambda. Wave number V bar, that is equal to 1 by lambda. So mu is equal to V bar into C. These two, from this equation you can find anything. Frequency also you can find, energy also find, wavelength and radius. So this is all about Bohr model or hydrogen spectrum mode. Okay, thank you.